Hey guys, it's Miss Sasu. We're going to go ahead and get started with our Unit 9 test review. I'm going to do the A problems first, and then we'll go through the B problems. So 1A says use the equation to find the following. And the equation they gave me is y equals negative x squared minus 4x plus 8. So since they gave me an equation, they want me to find the key features, which is the axis of symmetry, vertex, y-intercept, min or max, and min or max value. I know they gave me an equation, so I can just type that in the calculator. Okay, so I'm going to go to my graph. Either you can add a graph or you can do it on your scratch pad. If you don't have a TI Inspire, you can also do this in Desmos. So we know f of x and y is the same thing. So I'm going to type negative x squared minus 4x plus 8. And then I'm going to press enter. Okay. Now I cannot see this whole graph, so I'm going to zoom out using menu 4 and 4. And I'm going to zoom out from the center. So now I can see the whole graph, and that includes my vertex and everything that I need to see. So from here, I'm going to trace the graph. The way I trace the graph is by using menu 5-1. And the great thing about this is as I scroll on the graph, those answers are going to pop up. Okay, it's going to tell me what my y-intercept is. So it tells me my y-intercept, it tells me my vertex, and even tells me that my vertex is a maximum value. Okay, so it's going to either say min or max. For this particular problem, it actually says max. And yeah, once we have those, I mean, it tells us some other cool stuff on the calculator, our zeros, our solutions, and all that. However, let's just go ahead and stick with what they gave me. So we know we had our vertex, which was negative 2 and 12. And let me scroll back to that so you guys can clearly see it. Our vertex is our highest or lowest point on the graph. Okay, we just said that it's a maximum. So I'm going to go ahead and circle maximum. And then when it asks us for our maximum value, that's always our y value of our vertex. So our maximum value is going to be 12 because it's not going to go higher than 12 on the y-axis. All right, my y-intercept, of course, that's where the graph crosses the y-axis, and that's 0, 8. And we know our axis of symmetry, it actually goes straight through our vertex. It's the vertical line that splits our vertex right in half. Okay, so I'm going to go back to that vertex. And we know it's going to be a vertical line that's going to go straight through negative 2. I know it's negative 2 because that's the x value in my vertex. So I need to make sure I write x equals negative 2. If you don't put the x equals, that's not going to count. So make sure you put x equals negative 2. Okay, and that's 1A. 2A, they gave us a graph this time, so it's a little bit easier. I don't have to worry about putting it in a calculator or doing it algebraically. So again, my axis of symmetry is the line that splits straight through our vertex. Okay, and it's going through negative 2 on the x-axis. So I'm going to put x equals negative 2. Our vertex is our highest or lowest point on our graph. And that vertex is here. And that appears to be at negative 2 and 3. So I want to make sure I write that as a coordinate point, negative 2 and 3. All right, my y-intercept is where the graph crosses the y-axis, and it appears as if this graph, we can't see it. We probably should have gave you one or a picture of one that you can actually see it. So I'll just kind of estimate here. It looks like if it kept going, it might hit at around 7. So that's going to be 0, 7. I promise you on a test, we will give you a graph that actually is crossing, so that'll be easier for you guys. Okay. We know our roots, solutions, zeros, and x-intercept. Those are all the same thing. So I want to look at my x-axis. And as you see, it actually does not cross. So that means we have no x-intercepts, which means we also have no solution or no real solution. In Algebra 2, you'll talk about different types of solutions, but since it's not crossing the x-axis, you won't have any solutions, zeros, x-intercepts, none of that. All right. My since my vertex is at the bottom, this is going to be a minimum value. Okay, so I want to circle minimum. And I know that that value of the minimum is going to be positive 3. Because it's always our y value of our vertex, and that graph is not going to go any lower than 3. Okay, domain for a quadratic function is always all real numbers. Okay, unless they give you a type of scenario or they give you any holes in the graph that will restrict it, it's always going to be all real numbers. Okay, and the reason why it's like that is because, and we're going to assume it's arrows here. It doesn't necessarily have to have arrows to indicate that it's going to keep going. But with quadratic functions, you know, you're going to keep going to the left and you're going to keep going to the right. And that's going to give you all real numbers from negative infinity to positive infinity. For your range, we know that's our y. And let me write that because domain and range x and y. Okay, so our range, we're looking at where we start and where we stop. Again, we said that our minimum value was 3. So when we say minimum, it cannot go any lower than 3. Okay, which means that all my y values are greater than or equal to 3. All right, and that's 2a. All right, let's move on to 3a. Okay, so this one is fun. You're going to state the transformations from the parent function y equals x squared. Okay, so I'm going to show you 2 different ways because you should know how to do this by hand. And we gave you all vertex form, which is f of x equals a times x minus h squared plus k. That's also on the formula sheet, so if you forget, feel free to look and find it on your formula sheet so that can help you. Not cheat. We don't want you to do that. So we know that each letter does something. We know that our A is our vertical stretch and compression or reflection. We know that our H is our horizontal shifts. And we know that our K is our vertical shifts up and down. Okay, so I can look at each number and I can identify what's happening. So if my A is -2, that means I'm going to have a vertical stretch, which means that graph is going to get narrow. Okay, I'm also going to have a vertical reflection because of that negative. Anytime you have a negative A value, it's going to flip over the x-axis. So let's actually write the vertical reflection over the x-axis. Okay, excuse my handwriting, it's kind of messy. Then we're going to move on to our H. Okay, now one thing about our H is it's always the opposite because our formula has a negative in it. So my H value is actually 7, positive 7. Okay, so when you see it like this means that it's going to go 7 units to the right. So that's going to be a horizontal shift right 7 units. All right. Then our last transformation is going to be our K, which is vertical. and we said that that's positive 4. That's actually true to what it says it is. So it's going to be a vertical shift up 4 units. Okay, now on a test, it'll most of these will be multiple choice, so you just need to be able to see what it does. So yeah, make sure you know what each transformation is. If you don't, you can actually type both of your functions in the calculator. So I'm going to clear this out using DocB. And they started off with the parent function. So I'm going to put that parent function in first, like so. Then I'm going to press tab so I can enter in another function. Okay, so I'm going to type in -2 times x minus 7, just the way it appears on the paper. Close parentheses, squared, plus 4. Okay, so now we have a visual representation of what actually happened to our graph. And as you can see, it did go over to the right 7 units, as we said. It flipped, so it did reflect, but after it was reflected, it did go up those 4 units. Okay, so either you need to be able to look at the equation and tell, like, hey, this is what each letter does, or this is what each number does, or you can type in the calculator and see for yourself and make those observations for yourself. Okay, now when it comes to the vertex, we give you the vertex in the problem, which is your h and k. Remember, we said that our h is the opposite because we have a negative, so that h value is going to be 7 and our k value is going to be 4. So our vertex is 7, 4. Okay, and again, you can also trace that in the calculator. So I can say menu 5, 1. I'm going to press up to go to the red one, and I'm going to trace. It's just going to take a little while, but here we are. And there's our 7, 4. All right, let's move on to our next one. All right, so this one is pretty straightforward. We want to write our equation in standard form. Our standard form is ax squared plus bx plus c equals 0. So all I need to do is set this to equal 0. I have that -6 on the right side. So what I want to do is I want to add 6 to both sides. Okay. Now I am putting that 6 under that 5x, but keep in mind those are not like terms. So I'm not actually going to combine them. So I'm going to bring down my 3x squared. I'm going to have -5x plus 6 equals 0. And here we are. We have our equation in standard form. All right, and then our last problem. This is going to be a lot. I'm hoping I don't get cut off on this video. But we're going to solve using the quadratic formula. Okay. The quadratic formula is given to you on a formula sheet as well, so it's nothing that you have to memorize. And we're going to have x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so I first want to identify my a, b, and c. So my a is 1, my b is 2, and my c is -8. So what's going to happen is everything is going to go where they say is going to go. My b's are going to go where b is, my a is going to go where a is, and my c is going to go where c is. Everything that I didn't highlight is just going to come down. Okay, so I'll have x equals -2. That's my b. I have plus or minus 2 squared minus 4 times 1 times -8, all divided by 2 times 1. Okay, and let me color this again so you guys can see how we substituted these numbers in.